Hi there, this is Mr. Baker Street Roche and his accomplice Wilson. And welcome to Mr. Roche's Flip Class Math 10 No Frills, No Thrills, Low Budget, Low Tech videos. We're going to today do Linear Relations Part 3. Specifically, it's about parallel and perpendicular lines. So in this section, we'll be comparing slopes of parallel lines, comparing slopes of perpendicular lines, and finding an equation of a line that passes through a given point and is either parallel or perpendicular to some other line. So here we go. Wilson, sit in your unusual spot. Okay, first let's look at some parallel lines. Compare the slopes of these parallel lines. You'll see all three of those are parallel lines. That means they don't go together, converge, or go apart, diverge. They're stay equidistance apart. So this first one, I'm going to draw my usual right triangle to find the rise over run. We're going to find two nice spots like here and here. Here's my right triangle, and my rise is -2. And my run is 1, 2, 3, 4, 5, 6. So that is -1/3. That is my slope. My green line, doesn't matter where I go. This one is also -2/6, or -1/3. My red line, just for something different, I'll put my triangle below and try two different points. I'll try, this one and this one. This time I have -3 and a run of 9. So my rise is -3, my run is 9, but it still reduces to -1/3. So in other words, the slope of all parallel lines will be equal. Here's three more lines in slope-intercept form. If we look at those, we should be able to tell which ones are parallel. Well, this has a slope of 5, this is -5, and this is 5. So which ones are parallel? Yeah, I'm sure you guessed it. This one and this one are parallel. This one is not. Now we're going to look at some perpendicular lines. By the way, perpendicular means lines that meet or cross at right angles or at 90 degrees. Okay, so in this case we have a blue line. I'm going to go from here to say here. We have a rise of -3 over run of 1, 2, 3, 4, 5, 6. Coincidentally the same as the last picture. Oh, actually it isn't. It's not. It's a little bit steeper. The last one was -1/3. Okay, and the green one, which is perpendicular, if I find the slope of that one, let's see, here's a good spot and here's a good spot. This time, the rise is 1, 2, 3, 4, actually a drop of 4. And over to the left of 2. So we have a slope of 2. Notice it's a positive slope. Okay, interesting. You see how these compare? Okay, let's try another set. This one here. If I go from here to say here, we have a drop of 3. And to the left, 1. So that has a slope of 3, a pretty steep line. The green one, on the other hand, I go from, say, here to here. I have a drop of 3. 1, 2, 3, that's my rise, -3. My run is 1, 2, 3, 4, 5, 6, 7, 8, 9. My run is +9. So my slope is +1/3. Notice how these two compare. Whoops. Negative divided positive, -1/3. Notice how these compare. And after doing many of these, you'll notice there's definitely a connection. Perpendicular lines have slopes that are reciprocals, okay, and opposite. So I'll call them opposite reciprocals. If we multiply these two together, we get -1. If we multiply regular reciprocals together, we just get 1. But we've got opposite reciprocals, a product of -1. So in summary, parallel lines always have slopes that are equal. Perpendicular lines always have slopes that are opposite reciprocals. So here's some more examples. Let's see if we can find some parallel lines. Well, this is a slope, a slope, a slope, a slope, a slope, and a slope. So do you see any that are the same? Well, I do. Here's one. Oh, no, I don't see one that is parallel to it. How about -7? Yes, these two are parallel. And this one and this one are parallel. Do you see any that are perpendicular? Now we're looking for opposite reciprocals. This one is 7, this is -1/7. These two are perpendicular. Are there any others? Yes, +1/7 and -7. These two are perpendicular. I need a haircut. Okay, so part 3 is finding equations of a line in this form. Okay, we're going to learn about 2 other forms, but right now we're limited to this form. So let's use that. First example says finding the equation of a line that passes through point 10, 4, or the point with coordinates 10, 4, and is perpendicular to this line. Okay, well, we have 2 important pieces of information. This, and we know the slope is going to be perpendicular to that one, which is -1/5. Okay, so using this form, y equals mx plus b. What do we know? Well, we know that this other line is going to pass through that point, so that point will satisfy this equation or work in the equation. So I'm going to substitute this in for this x, for this 10 for this x, and this 4 for this y. So the y is 4 equals, and I know the slope of the perpendicular line is -1/5. So -1/5 times x, which is 10, plus b. So I just have to calculate b using algebra now. So I can reduce this a bit. That's a 2. So I have 4 equals -1 times 2 is -2 plus b. And now b equals, add 2 to both sides or bring this over as +2 and I get 6. Okay, so now my final equation, I have the generic one. Y equals -1/5 x plus 6. Okay, so that is the equation of that line. It'll have y-intercept 6 and a slope of -1/5. Okay, one final example. Find the equation of a line that is parallel to this line and has an x-intercept of -15. Okay, well, that's important. It's got an x-intercept of -15. I know the coordinates of that point are -15 is the x coordinate, and the y coordinate is 0 because it's on the x-axis. And I also know that this is the slope of the original line, and I want one that is parallel to it. Okay, so let's start off. Y equals mx plus b. I know this point will work in here for x and y, so the y would be 0. The slope is the same as this, -2/3, because it's parallel, times x, which is -15, plus b. Now we solve for b. Okay, I can reduce this a bit. That's 1 and this is 3. So now I have, whoop, low tech, remember I've got to fix it. That would be 5, -5. Okay, so now we have 0 equals -2 times -5 is +10 plus b. So b equals, bring that over as -10. So our equation now is y equals -2/3, same slope as the original, x minus 10. That's my answer. Okay, so that's it for now. As usual, if you have any questions on your assignment, come and ask, and